Hi, today I'm going to go over another type of solving a system of algebraic equations. So in the last video, we solved systems of algebraic equations. Basically, two equations, both an x and a y, that we had to find the value of by substitution, right? We find the value of one, and then we plug it in for the other. But today, I'm going to introduce a new strategy that, for some problems, is a lot faster and a lot easier. And that's called elimination. What is that? Well, we'll soon see. So, let's do an example problem. Say I'm given a problem like this. X minus y equals 11, and 2x plus y equals 19. Now, if I wanted to solve this, like we've been solving this, I have to take one of these equations and put this in terms of a variable, right? So for this equation, I could add y on both sides, and I get x equals y plus 11. And I then have to substitute that in for x in this equation, distribute all this out, manipulate it, yada yada yada. A lot of work, but there's a lot faster way. There's a way that I can get it so I have an equation in terms of one variable with only a single step for this exact equation. How do I do that? Well, I say, what if I try to cancel a variable out? You might be saying, what do you mean cancel a variable out? What are you talking about? Well, if I were to add these two equations together, or I would add this equation and this equation, I'd start out simple, right? X plus 2x is 3x. Negative y plus y. Well, that's the same thing as y minus y. That's actually 0y. I've entirely canceled out my y term just by adding them together. And then over here I have 11 plus 19, which is 30. So really I have 3x minus 30. So in a single step, I've just canceled out an entire variable. And now solving is pretty easy. I divide by 3, and I get x equals 10. And of course, if I wanted to find y, I could plug this value back into the original equation, right? I'd have 10 minus y equals 11. I'm going to just subtract 10. I get negative y equals 1, so y equals negative 1. So I have x equals 10 and y equals negative 1. Really simple. You might be saying, okay, I see a pattern. Whenever I have a system of equations where a set of variables has the same coefficient, right, in this case 1, the same number of variables, but opposite signs, I add them together and I cancel the variable. Okay, cool. And you're right. This does work for any type of problem like that. For example, if I was given something like this, 4x plus 8y equals 20, and negative 4x plus 2y equals negative 30. I say, this is 4x. This is negative 4x. These have the same absolute value, the same value, but different signs. Which means if I add the two equations together, these guys are just going to cancel right out. 4x plus a negative 4x, that's a 0x. So I'm left in terms of y. Plus 10y equals negative 10. And now it's really easy to solve. I just divide by 10 on both sides. And I get y equals negative 1. Really simple. And of course, if I wanted to find x, I plug it back into my original value and solve from there. But very, very easy. But believe it or not, you can use elimination in cases where you might not expect it, right? Say I was given something like this. 8x plus y equals negative 16. I have negative 3x plus y equals negative 5. Now you might be saying those two y's and say, oh, if I add 3x to this side, I'll get y equals 3x minus 5. I just plug that in and boom, I'm done. Be careful. There's also a way to solve this by elimination that's just as fast. Now what is that way? I know that I can cancel these two y's out if I subtract them, right? Y minus y, that's 0. So then how do I subtract them? Well, put simply, I subtract the entire equations. I subtract this entire equation from this entire equation. What does that look like? Well, I have 8x minus negative 3x plus y minus y is equal to negative 16 minus negative 5. I always recommend writing this out like this, especially if you're uncertain, right? It's 8x, then your operation, then this. So 8x minus negative 3x. And now we go ahead and we simplify. So we have a double negative, that's a positive. Now we simplify. We combine like terms. This is 0. And this is negative 11. Divide by 11 here. And I get x equals negative 1. All right, so just like that, I have my x. I can plug it back in and easily find my y. So what was the key observation here? Well, just like we said, hey, if I have two variables with the same value but opposite signs, I add and I cancel. Well, here, if I have two variables with the same value and the same sign, I subtract, cancel. So different signs, add. Same signs, subtract. Either way, you get an equation in terms of one variable, you get that value, you plug it in, you solve your entire equation. Nice and easy. But there's one other thing, one other topic that you have to cover with elimination. And that comes down to the will of the teachers. Now sometimes we'll have a teacher that says, you must use elimination to solve these problems. So what are you going to do? Let me give you an example. Say it's something like this. Negative 7x plus y equals negative 19. And negative 2x plus 3y equals negative 19. And your teacher said on this, hypothetical worksheet, you must solve this using substitution. Right? What are you going to do? Well, you solve this using elimination. What are you going to do? Well, we know elimination basically involves us canceling out one variable, right? So how are we going to cancel out one variable? Let's look at the y's, right? If these were both 3y, it'd be very easy to cancel. I just subtract the equations, be left with 0, but they're not. If I subtract the equations, I'll have negative 2y, which doesn't help me because I'll still have the x's sitting around here. So how can I get to the point that these are both 3y? Well, I know. I'll multiply this entire equation by 3. Because if I do that, this will become 3y, and I can just subtract the two equations and get my answer. So I'm going to do exactly that. So 3 times this. Well, 3 times negative 7, that's negative 21x. 3 times y, that's 3y. And 3 times negative 19, that's negative 57. All right, now we subtract. All right, negative 2x minus negative 21x plus 3y minus 3y is equal to negative 19 minus negative 57. And I say, oh, I have done my double negatives. Those turn into positives. And now I'm going to solve. So, 21x minus 2x, same thing as 19x. 3y minus 3y, that's 0. 57 minus 19, that's 38. So what I really have, I'm going to go up here for a bit. What I really have is 19x equals 38. Now I have a single step equation. Divide by 19. I get x equals 2. And if sure enough, if I wanted to find y, it's a simple process. I go into either one of these equations, I plug in 2 for x, and I just solve for y. Now this is messy, I'll admit. But it can be key, because there will be times where you will have to use elimination. And there will be times where you have to use elimination where you won't have an easy elimination trick like we did earlier. In those cases, you're going to have to multiply one equation by a certain value to get it so that both of a variable have something that you can cancel with, right? So, for example, this was negative y. We'd still multiply by 3, but this time we would add the two equations together because negative 3y plus 3y would get us 0y. So, be adaptable. Look for patterns, right? If we have the same signs, we're going to subtract the equations. Different sides, we're going to add the equations. If we don't have the same coefficient out in front, we're going to multiply by something to get it so we do have the same coefficient out in front. That is all you need to know for elimination. I hope you found that helpful. I hope you have a great day.